Hey, super scientist. In PT2, we're going to be looking at metals and characteristics of metals. So think of some things that you know of that are metal. What kind of characteristics might they have? These are some pretty common metals that a lot of you may be familiar with. Some of these are elements, and some of them, like brass, are going to be alloys, which means they're mixtures of different types of metals. So what are properties of metals? These pictures show you some of the different types of properties that a lot of metals exhibit. Shiny, which means they have a high luster, they're very reflective of light. Malleable, which means that they can be bent or shaped. These coins show an example of malleability because those coins have been hammered into a specific shape, but also have this impression hammered into the metal. Ductile. Ductile means it can be pulled into wires. So it can be pulled into shapes like using for these chain link or copper tubing in refrigeration. Good conductors. A lot of metals are going to be good conductors of heat or electricity. Most metals are solids at room temperature. Mercury is a liquid metal that some of you may have heard of before. Bismuth right here, this is my favorite metal. It's just a beautiful array of color, kind of a rainbow. And some of them have different characteristics too, like magnetism, for example, with this magnet. Metals, most of them are going to have a high melting point and density. So the high melting point means that it has to get to a really high temperature in order for it to melt and turn from a solid to a liquid. So metals on the periodic table. Metals are going to cover most of the periodic table, and so they're going to be divided into different groups, and they're arranged based on properties and similarities of different properties. So group 1 is going to be the alkali metals. Notice how this is started with lithium. This is the first group on the left-hand side of the periodic table. Right above lithium is hydrogen. So hydrogen is kind of by itself. Hydrogen is not a metal, but it is number 1 as the atomic number, and so that's why it's at the top of this particular group. So the metals that are in group 1 are the alkali metals. Their common property is that they explode when they are mixed with water. They are highly reactive with water, so they literally will catch on fire and explode. There's a lot of cool videos online showing the alkali metals. And they are really reactive because they can easily lose one electron. They have kind of this one extra electron in their valence shell, and they will try to give that electron away. They try to get rid of it. So some different examples of things you may be familiar with that include some of these different alkali metals. Salt. Salt is going to contain sodium, but if you put salt in water, it does not explode, right? And that's because it's sodium chloride. It has sodium and chlorine combined together in a compound. So it has different properties, but it does include sodium. Potassium. Same thing, if you were to randomly throw a banana in water, not going to explode. It has lots of different things that are in it. So this explosive when mixed with water thing, that is just about the pure element. So usually these elements, when they are in their pure form, are going to be stored in some kind of oil. Group 2 elements are the alkaline earth metals. They also are very reactive, and you may know them from fireworks. If you've watched some 4th of July fireworks, you may have noticed lots of different colors. Strontium is one that produces red coloration. Magnesium, another example, it produces white colored fireworks. And a lot of different alkaline earth metals are used in things that are common or things that you may have heard of. Calcium. Calcium is in milk. It makes your bones strong, right? Barium is something that's used in the medical field and is radioactive and used to produce this to show up on x-rays or different images if you are looking at the internal organs like the digestive system in this example. Transition metals. So the transition metals are group 3 through 12. There's this large section in the center of the periodic table, and the transition metals are not going to be really reactive. They are going to be used for a lot of common household purposes, which means that we can use them for cooking and cleaning and jewelry, and can use them in lots of different compounds, and they are not reactive. They are going to be pretty unreactive. So they have high melting points and high boiling points, which means that it's going to take a lot of energy in order for it to melt, and also is going to require a lot of energy in order for it to boil and start transitioning from liquid to a gas. The metals in mixed groups are going to be towards the bottom of group 13 through 15. They're also sometimes referred to as the post-transition metals. So these elements, these metals, are going to include tin, aluminum, and lead. So they are metals, but they, at the beginning or the top of their group, will contain either nonmetals, metalloids, or some combination of those. Our next group are the lanthanides. So if you look at the very bottom of the periodic table, we have these two groups that are separated from the rest of the periodic table. And these are the lanthanides in this darker blue and the actinides at the bottom here. So the lanthanides are going to include some things that you may be familiar with, but these are some properties specifically about lanthanides. They're going to usually be fairly soft and malleable. They are shiny like other metals and have good conductivity. They are very reactive and they burn easily. Holmium is one example that's used in machinery at hospitals like MRI machines. Neodymium is something that you're probably familiar with. Neodymium is a really strong magnet, so it's going to be used in speakers and headphones. And the actinides. So the actinides are the very bottom row on the periodic table. The actinides are going to be unstable, so they're going to be radioactive. They're going to lose their or give off a lot of energy as they are breaking down. And a lot of them are going to tarnish in the air. So when they're exposed to the air, they will tarnish. Some examples of these actinides are einsteinium, thorium, curium. So they're going to have metallic properties, but also are very unique because of this instability and radioactivity. And the last group are different synthetic elements. So this isn't necessarily a different group on the periodic table, but some of the elements on the periodic table are synthetic, which means that they have been man-made. They are not found naturally on Earth. So scientists are going to use these different types of equipment called particle accelerators, which are actually really large pieces of equipment, and that will help to create synthetic elements. So this is a picture of a particle accelerator. And this is kind of the cap that goes onto it right here. So this is really large. It takes up an entire room. So a particle accelerator is going to take two different atoms, two different elements, and basically will spin them so fast that their nuclei will fuse together. They will crash into one another, and that will form new elements. A lot of times those new elements are not stable. So an example is curium. Curium was created by colliding helium and plutonium, technetium, americium. So those are just some different examples of elements that are synthetic that you may have heard of before, or may have an example of technetium is used in different medical equipment.